You're listening to Within Tolerance, a podcast for machinists by machinists. I'm your host, Dylan Jackson from Proteum Machining, and this week I'm joined by Brandon Poythress of MarkZero Prototypes. Welcome, Brandon.
Thank you so much for having me.
Yeah, thanks for joining me. So, what is MarkZero Prototypes? What do you guys do? Where can people find you? All the good stuff.
Yeah. So the company is MarkZero Prototypes, and on Instagram, it's just MarkZero Prototypes. The website is markzeropro.com. And the company, revenue-wise, is about 70% design work and about 30% job shop stuff. And mainly that 30% is whenever the machines or the machine, I shouldn't overinflate myself here. The machine is available, not doing the engineering and design tasks. I try to keep it busy just to stay alive, like any business. And the business is called MarkZero, not because my name is Mark or my last name is not Zero, but it's actually a nod to the Navy and their revision system. Because in the Navy, instead of using revision A, B, C, or 0, 1, 2, they use mark numbers, which is why in the Iron Man movies, the suits are the Mark 40 and the Mark 41 and stuff like that. So that's the business, and I can go into the backstory or...
Yeah. So how did you get into manufacturing, and then how did you start MarkZero?
Yeah, right. So I grew up in Houston, Texas. I graduated from the United States Naval Academy in 2006 with a degree in naval architecture. And naval architecture is a very small, specialized engineering degree that focuses mainly on combining the structural and mechanical aspects and combining them into ship design. And it's not offered very many places. The Naval Academy is one in Michigan, but it's the Navy is really the big customer of those graduates because of their need to design and build ships. So I was commissioned in 06 as a naval officer, but at the time there was a program called the Blue to Green program that allowed anyone in the Navy or in the Air Force to transfer over to the Army. And I figured I didn't have a lot of direction at that time, and I felt like it'd be kind of cool to do that, so I did. And then, a few months later, I ended up in Mosul, Iraq, as a infantry platoon leader. But quickly after I was commissioned, I realized that long term the military really wasn't going to be for me. I got out and I briefly worked for Amazon.com actually in Pennsylvania as an area manager, which was less than pleasant. I wouldn't recommend that to anybody who's listening. I can't say any more because Lex Luthor will come for me. But yeah, so I was looking for what I really wanted to do when I grew up, even though I was older, and I was still looking for what I wanted to do with my life. So I got my first engineering job, my proper engineering job, at a company called FMC Technologies in Houston. And it was a great job. I designed subsea oil and gas equipment, predominantly like large high pressure systems. Like the materials were exotic, the control system were complicated, the systems are super high risk, super deep water. And it was my first introduction to manufacturing. My cubicle was above the manufacturing floor, and the weapon of choice was like large horizontal boring mills, because oil and gas equipment, especially subsea oil and gas equipment, is really big. So it was dominated by big horizontal boring mills. But the shop had almost everything you could possibly imagine. But I had no idea what that stuff was. And I was, in the engineering department, I was insulated from it because there was a manufacturing engineer that was my interface with that. And I didn't really bother with it much. And I actually, surprisingly, didn't learn that much about designing for manufacturing there because there was such a distance from me to the actual shop floor in practice. But that job, it was such a good place to work. It was when oil was at like $120 a barrel. And so like the Christmas party, it was a big company. The Christmas parties were like, Wolf of Wall Street. It was just like such a great time to be in the oil business in Texas. I don't know how else to describe it other than that. And it introduced me to how like a big engineering firm works, in a big picture. And it was very segmented. Like there was engineers, there was FEA analysts, there was purchasers, there was quality people, there was material specialists, and then manufacturing engineers, and all that stuff. And they were all moving pieces in like a big organization. It also showed me how FEA was integrated into design, like in a real company, not just in like a software, how you use finite element analysis in design. And at that time, I took a pretty heavy interest in software engineering because the FEA teams would would control a lot of their simulations using Python scripts. So I kind of dove into that while I was there, and that love of writing code has actually stayed with me since. I love the job, and I was a little bit older for being like an entry level engineer. I was a little bit older because of my military time, which helped me a little bit. I felt like I kind of moved up quickly there, and maybe it's a little bit was age. I don't know, but yeah, it was great, and I probably would have never left, at least not in the near term. But my wife was a chef, or she is a chef, and she wanted to live in New Orleans because if you're in that business, you want to be in New Orleans for a little while because of the food culture there. And so I took a job as a naval architect at the American Bureau of Shipping and was responsible for ship structural review. So very little machine components there. The oil and gas business was a lot of machine components, a lot of mechanical design. Whereas when I worked at the Bureau of Shipping, it was all structural design, so welded fabrications. And I would review, ship designs from shipyards that were building vessels, and put the stamp of approval on it on behalf of whoever. I didn't really like that job. It was like being a government employee. Nothing against that. It's just for me, it wasn't a good fit. You weren't really in the fight yourself. You were just kind of like being the referee, which I didn't really care for.
Makes sense.
But I did learn a lot about like large scale structural fabrication, which was cool. It really helped me later on. But at about that time, I was eligible to, sit for my professional engineering exam. And so I did that and passed. And so I was licensed first in Louisiana, and then shortly after in New York. And I was looking for, where I should go. I wanted to find like a small engineering company where I could really like do everything. And I found this awesome company called Walls and Krenzer in Connecticut. And it was like a 50-50 split of naval architects and mechanical engineers. They designed custom flood barriers for buildings and doors and hatches for ships. Anything that held back water, they would design. And that was my true introduction to the realities of manufacturing, because the company was so small, every problem that occurred was directly on whoever the engineer's plate was who was designing it. So any fabrication issue, any QA issue, any purchasing issue, we were writing our own POs. We did like the complete spectrum of the life cycle of the project was in each individual engineer's hands, which was cool, but it made me like so close to the manufacturing of the items because there was no one else to do it. So we did subcontract basically the structures are comprised of like big welded structure merged with a bunch of smaller mechanical components that control them opening or closing or latching or doing any type of sensing that's required. And you can actually see these barriers at the entrances of the tunnels, like in New York City, like all the main tunnels that lead into Manhattan. There's big swinging gates there that are about 40,000 pounds that basically block off the tunnels in the event of a hurricane or a large flood. And also in the entrances to any of the subways that are in Lower Manhattan, like Broad Street, Rector Street, South Ferry Terminal, stuff like that. And the barriers for manufacturing, they were like the worst possible combination. They were like never the same, right? They were complicated. They were often made of like super expensive material, and they were really tightly toleranced. And they were big. Like we'd ask them to hold like an 1/8 inch over 40 feet, you know what I mean? Like on a structure. And they just hated us, like everybody hated, manufacturers hated, they loved us because we paid, but like they hated us for every other reason,
Yeah.
And like imagine you, like if I contacted you for a quote and I said, all right, check it out. I want you to quote 1,000 parts, all of them quantity of one. and each one, they'll never be ordered again.
Right.
So,
Yeah.
and I want a really good price on this. You know what I mean? It's like, it's the worst combination. Like you don't want that. And we did it all turnkey. So we would go normally to one vendor and say, a big fabrication facility and say, turnkey, here's the whole assembly, make all of it, put it together and test it and ship it. Right. And over time, what would happen is that we would experiment with manufacturers. And at first they would look at our budget and be like, this is awesome. I'm in. I'm going to make this customer so happy. And they would quote and they would do the first order, and the second order was always like double the cost of the first.
Yep.
Like they were, once they realized what they were in for, they were just super not happy about it.
I bet.
And And basically the way that the work was structured, it was just very undesirable for manufacturers. Manufacturers would always want to go for easier work if they could, and I now understand why, but I didn't then. I didn't ever hands-on do this type of building myself, so I didn't understand why everyone was so nasty to me. Basically, you know what I mean? I had no
Right.
idea. And what's funny is I had no idea, but technically at this point I was like a quote experienced engineer. Like I was a guy I would stamp your drawings. I was a guy you'd go to like ask these manufacturing questions, and I'd be like, oh yeah, I know how this all works. Let me tell you something, And I was just like totally full of crap, and I didn't know any better. I just thought that I would pick up bits and pieces, and I thought that I knew a lot and about manufacturing, but I didn't. So anyway, now we get to like the whole introduction to real manufacturing for me, and basically there was a job that was for Hoboken Station, which is in New Jersey, and we quoted 5 big barriers for the entrance of that station, and so we got a quote from our vendor, our shop, and it was, let's say, 100K per door. And so we took that 100K per door and we put our engineering costs on it, how much it would take for us to actually do the finished design work, and then to deliver it, we added our markup, and then we quoted it to the contractor, and then and they quoted it to the city. They quoted it to the transit authority there,
Right.
and the transit authority says, "Awesome, sounds good, go." So we go back to the manufacturer, and they say, "Hey, wait a minute. By the way, that was just a budgetary quote. It's actually going to be 200,000 per door. All right."
Woo.
So yeah, so it was very unpleasant for me because I was responsible for this whole quote. I mean, all this quoting was through me, and it was like I was all of a sudden in this hot seat because my company had an order that was basically unprofitable from the moment that it started. Like there was nowhere to go, and we couldn't say no to it. It's not like we're gonna like say no to the job because you don't like get a purchase order from the city and then say never mind.
Right. You're never going to work there again.
Yeah, exactly. So our vendor quotes, and that was the worst instance, but that was kind of the trend on all of our suppliers. And the quotes became so restrictive that as an engineer, we lost all design freedom at all. Like there was like a joke that everything we designed, every single thing had to be simply made of McMaster car nuts, you know, like that were somehow pieced together because
Right.
any other design beyond McMaster car nuts was too expensive. And it forced me down this really nasty road of negotiation between my suppliers, not for money, yes, but like more so like, okay, if I do this instead of that, if I do this instead of that, if I do this instead of that, over and over again, like we'd be looking at the smallest of D to try to like get the cost down of these items. Well, what if I got rid of these machine components? What if I changed the finishes? What if I changed these chamfers into fillets or fillets into chamfers? Like all those discussions happened fast and furious and in like this pressure cooker. But in the end, I just couldn't do things cheap enough. And at this time, our primary shop that we use most of the time was going out of business. And I pitched the owners of Walls and Krenzer an idea like, what if I started a separate company and I designed, instead of designing flood barriers or hatches, I designed a system of manufacturing flood barriers and hatches. Like, what if we took the whole spectrum of your products or our products and figured out a way to purchase like machines kind of dedicated to a certain genre of part, and then in code and basically in the programming, you basically change parameters to make it the custom stuff, and then and see if we can squeeze out get these costs down so we can actually design again.
Right. You're talking like a parametric flood door, more
Right.
or less.
Yes, exactly. Like the fabrications could be kind of a generic template, and then the machined parts could be grouped into rough categories, and then those could be dedicated to machine tools that would work for it.
Right.
But the owners of Walden Pinzer are super smart, and they were like really excellent bosses, and they were really smart. And because they were smart, they had been down this road before, and they realized that, and they were probably correct, is that this had been tried through their previous suppliers, and it never really bore fruit or bared fruit. However the grammar works on that, I don't know. But anyway, they hadn't worked before, so they were like, that's a big risk, and it's not something that we would really want to, financially jump into. And after that shop that they were using went out of business, I can't blame them. Like they propped that shop up for a long time to make it survive, and it failed anyway. So they were like, if anything, we should be backing away from manufacturing and trying to spread it more and not going deeper into being merged with it. So they turned me down, but by that time, I had already done all the research, and I was like deep in the weeds. Like on machinery. I was looking at like gantry mills, water jet machines, CNC mills, lathes, and the curiosity kind of like just took off. And once it started, I was like, okay, well they said no, but maybe they'll just change their mind if I show them that I can do so. I can prove this concept a little bit more. Maybe they'll come around. So I bought like a Tormach 770, and I was like, all right, I've arrived. And then, yeah, like in that moment, first of all, it took me about 2 weeks to grow out of that machine. That's about it, like about 2 weeks.
Yeah.
But also it like I was like, oh man, now I see what, because I started making parts. I was like, I'm just going to take parts from anywhere. I don't care how cheap they are, if they're profitable. I'm just going to start making parts so that I have to go through this process over and over and over again and see like what making parts is really like, and why manufacturers aren't very receptive to these things. And just like growing out of the machine, within a couple weeks, I was like, oh, okay, like I get it. Like
Yeah.
I understand now. Just like the nuance of it. It's like it's an art. It's not a science. It's the what it boiled down to was, the main driver is that the high labor cost of high mix, low volume manufacturing is just brutal.
It's tough.
And yeah, and the Walls and Krenzer parts were the highest mix and the lowest volume that you could possibly imagine at the biggest scale.
Yeah.
And
And they're difficult too. Like,
and they're hard.
yeah.
Yeah, and they were
There,
hard.
there's something about, I mean, if you're doing onesie twosies, little donuts of aluminum, it's not that bad. But when you're constantly having to re-innovate everything every time for a new material, that could be really rough. I could see.
Yes, it was really really rough. Yeah. So anyway, so I was kind of down in the dumps because I'd always wanted to start a business, and this problem had captivated me. And Walls and Krenzer wasn't really willing to take the risk, which again I think that they were correct in that, and they were very smart to do that, because I would have probably it could have been great, but I also could have driven them to the ground too. So it's hard to say what the outcome would have been, but like I decided to launch a company anyway, and I put a lot of faith in this submission to the National Science Foundation. And basically, every time I made a part when I was trying to doing all this research for the company, I would like make a list of everything that I did. Like, okay, I had to select material, I had to walk to the machine, I had to open the vise, I decide how I'm going to use the vise or another work holding. Like every little piece of the puzzle. Like, okay, the tool is really this long, but I could push it to this long if I needed to. All those things that machinists do, I kept like a record of. I like wrote it down. I'm like every step, like how tight do I tighten the vise? Why do I choose that? Why do I choose to hold it in this way? Why do I choose soft jaws here instead of something else? I tried to like catalog all those decisions that I was making, and also decisions about rigidity. Like I know that this tool and this speed and feed will work, and why do I know that? Like why do I feel that that's good, and why not? And I would try to keep track of those types of things. And so I pitched this idea it's called an SBIR grant with the National Science Foundation,
Mm-hmm.
where I would take like a year and try to cram all that into a software package, basically. And the concept was, is it possible to drag and drop a 3D file into a piece of software and have it analyze the part, and then decide the best way to hold it, and then recommend a series of operations to machine it, and then present that to the machinist or the programmer, so that he has and it's not just like templates like you have in Fusion where it's just steps. It's like actually making intelligent decisions based on the geometry of the part. And imagine like a shop floor, maybe, that you when you set up the software, maybe you build kind of a virtual machine, like a clone of your machine, and you put in parameters for how you hold, what your options are for holding, how big your vices are, what they look like, and all that stuff. And then see if you could actually have any traction like with a software like that, to try to see if you could get meaningful results. So I submitted that, and they hated it. Like,
Really?
yeah, they hated it. It was brutal. Like they gave me like a lot of good feedback, and I like honest feedback, so a lot of it I really appreciated. But they really didn't go for it, and The main reason they didn't like it was because of a submission that they had from another company. I think it was Proto Labs actually. So Proto Labs did the same thing,
Uh huh.
and in their submission they said that programming and setup time is not a primary driver of costs in manufacturing. That's something along those lines, like a paraphrasing. It's all like machine time and material. And so the reviewer took that snippet from their submission and basically quoted it and said, "This is not a good idea." And from my perspective, I get what they're saying, because for low mix, high volume, that absolutely makes sense. But for high mix, low volume, which is the world that I lived in,
That's all the
I
time.
it's all the time.
Yeah.
Right. Yeah, it's all the time. So I didn't get it. It really it hurt a little bit, but I just decided, screw it, I'm just gonna start the company anyway. So I quit my job and then rode the dragon, you know?
Yeah. Well, we've talked quite a bit about it because you you've echoed a lot of the sentiments that I've been feeling leading up to leaving my job, and it's nice to commiserate with somebody else about those. I mean, it's a tough decision. Like it's not certain waters, to just jump out and be like, well, I'm gonna make it work. I'm gonna build my parachute on the way down, kind of thing.
Yeah. Yeah, I understand how you feel, and I would never be like a guy who's like, you know, don't be weak, quit your job, stop being a baby about it. You know what I mean? Because
Right.
like, I was older. I started, my career 5 years after my peers, and so I had wife and kids and all that stuff, and I had all those things and expenses. But I have noticed that, who Rich Roll is?
Name sounds familiar, but I can't place it.
Yeah, he's like a really popular podcaster. Probably not the really focused on the demographic that you are, but he's out in California and he's very spiritual and all that stuff. But he has a very very popular podcast. And, he says that if when you quit your job, you're showing the universe that you're serious, and once the universe knows you're serious, it will conspire to help you. And so far, that has been my experience. I basically when I quit the day job, I basically planned in about 3 month increments. And I was like, can I survive the next 3 months? And I could. I'm like, okay, so I'm gonna breathe. I'm not gonna think about it or worry about it. I'm not gonna make myself crazy. And then, sure enough, when things start to dry up and I start to panic, something will come along. I either get a job that I can run on the machine, or I'll get a piece of design work, or something tends to happen to make you survive a little bit longer. So that was my experience. Maybe I was just lucky, but I think when you're doing it all the time, more of those opportunities show themselves to you too. So
So I want to get a little into your waves to water thing too. How did
oh
how did
yeah,
that come up? And because that's kind of my first introduction to you, was seeing all the designs, and we
right.
had talked over Instagram, but like every time I looked at your profile, that's what I saw was waves to water stuff. So where is that now? How did you get into it?
Yeah,
What's all
yeah.
that about?
Yeah, yeah. Well, let me tell you first, because so I'm notorious for sliding into DMs, and and I'll tell you the reason why. Basically, I'm not a machinist, right? So I had all of these challenges that real machinists don't have because they just know. So I basically would just kind of go on Instagram and like I have like a list of like 20 different people, and I'll just take turns asking questions to all of them, so that I don't bother someone too much. You know what I mean? Like if I have a problem with work holding, I'll be like, okay, now it's Dylan's turn, or what, and now and so I try not to overwhelm everyone, because I know that would be annoying, and maybe I am annoying to some, but like it's really my only resource. It's my primary resource to learn things. And I've done that less over time because I've gotten a little more proficient at running the machine. But in the beginning, I was really heavily like I think I even asked you guys about like what machine to buy. Like one of those like super groupie questions, like what machine do I buy? Like I don't know what to do,
Oh yeah,
and all that stuff. And you guys actually kind of had a big influence of what I bought, because I didn't know where to go because there's so many opinions out there.
yeah, there really is. And for the most part, what's nice about it is they're all relatively good choices. Like I have yet to see a machine on the market where, like, if you chose that, you would sink your company just based on that decision.
Oh, really? Even the feeler from, where is it from? Korea?
Okay, maybe there's one on the market.
Yeah, for those listening who don't know, a company tried to get me to program their machine, and I won't name it because they'd probably be upset. And I didn't know how to. I don't know a FANUC control at all, and so I passed that on to you.
Hmm.
And you're like, what machine is it? And I was like, a feeler. And I think you sent me like an emoji of like shivering because
Yeah.
you were terrified. Yeah. Yeah. Okay. So if you own a feeler out there, I'm sorry. I don't mean to be rude.
Well, the reason I had that reaction is that my business partner's day job has a feeler, and like, I don't think I've ever heard him say a good thing about it. And we've run parts over there. Like when we had to make the subplate for our Kitamura, we didn't have the travels for it, obviously, because it was a subplate for the machine, and we
Yeah.
ran it on that machine, and it was just like, it, it's just not great.
Yeah. Yeah.
I won't go into it too much and dig into it, but I
Yeah.
was not impressed. Let's just say that.
Right. Right.
So,
Well,
anyways,
okay.
back to waves to
Yeah,
water.
yeah, your question. Yeah. So basically I partnered with a company in Ireland. The Department of Energy and the National Renewable Energy Lab put on this contest open to anybody in the US that said, if you can build a thing that uses waves to turn salt water into fresh water and pump it to shore, and you can fit the whole thing into basically a pallet, you win. Or you're going to be in the running to win an overall prize of whatever. And there was like multiple phases. There was like a design phase, then there was a concept stage, a design stage, and then there was an adapt stage, which really was just giving extra time, I think, because of COVID. And then there was a build and a drink. And the drink stage is the final stage in the ocean where you actually are supposed to produce water, and they'll test it for its TDS level and see if it's really drinkable and see how much you produce. And then if you produce a lot of good water, you win. And then you can win second and third places for different things, like if it's easy to deploy and all that stuff. So anyway, we participated in that, and that's taken up quite a bit of my time. It's actually a pretty good program, and the actual people at the Renewable Energy Lab and the Department of Energy have been actually really good too, because I have to do like milestone meetings with them, and they've been really great. Like it wasn't what I expected. I expected kind of like a government thing where it was just all a little bit of a mess, but it wasn't. It was they actually like really knew what they wanted. And so anyway, we were successful. And every time there's a milestone, they cut teams. So it started with 100 teams, and then we got through that, and it was down to I don't know 20 or 30, and we got through that, and then so anyway, we're down to the last 10 teams, and each time you get hit a milestone, you get some money, and we use that money, we reinvest that money into the next phase to try to continue competing. And it's been really good, and we're into the final 10, and then the next cut is down to the final 7, and those 7 will actually go to a pier in North Carolina and deploy the device, and then it'll be evaluated for its final performance. And this has been like the most. So we designed it, and then we made some animations for. They required you to submit videos and stuff like that. So we did some animations, and then we built a test rig in my shop here. It's actually right behind me.
I was gonna say over your right shoulder, right? I was just looking at the
Yeah,
picture this morning.
yeah, yeah, yeah. And so we ran it through its paces, and we hope to get selected for the last 7. This phase has been really tough, because we've been running it through. We have a bench that basically simulates different sea states, and it oscillates it, because our design is basically like a hinge. It floats in the water, and then as the waves go up and down, it makes it oscillate like a hinge, and that hinge motion pumps a cylinder, and that cylinder pumps the seawater into an RO circuit, reverse osmosis circuit,
Hmm.
that then produces the fresh water. And it's real tricky. I mean, like water purification is trickier than you think, especially with seawater, because I don't know, do you have RO in your shop?
We've got a small system that we sort of use.
Yeah, so I have RO in my shop too for my VF2.
Hmm.
And when you have fresh water that's already fresh, pushing it through an RO membrane is the faucet pressure of 50 or 60 psi is plenty to push it through the membrane. But
Right.
when you have salt water, basically the osmotic pressure is so high that it takes like 900 psi.
Holy
So
crap!
yeah, so basically like the device has to amplify as it's wiggling around on the surface of the ocean and pumping seawater through it. It's not only pumping it at pressure, but it has to go through a series of boosters that basically bring the pressure up from atmospheric pressure to 900 psi to send it successfully through that membrane, that RO membrane. And it's tough. And during testing, we had some real challenges. Like we didn't meet all of our like what we expected we would by now. So the judges in this final stage are definitely within their rights to boot us this phase, but at the same time, we think we know how to solve those problems. It's just we don't have the time and money between now and the end of the month, basically, to fix it all. So we're hoping that there'll be, or maybe all the teams are having the same problem. We don't know. We have no idea what the last 10 teams are doing. But we manufactured a ton of stuff for this thing ourselves, like almost all of it. Like we made a custom valve that we machined here, all out of 316. All the structural components I did in the machine. And the only thing we bought off the shelf was really like the couplings and like the tubing and stuff like that. So it was such an advantage to be able to just build everything ourselves, like our own team, and not have to sub it out because I mean lead times were just ridiculously long. So it's all like I could do it in a day. I could like I think I did the valves in like from the time I finished the file and hit save on it to the time I had a valve in my hand was like 4 days or something like that.
Oh
It's
wow,
like you couldn't even imagine doing that if you subbed it out, unless you want to pay like thousands of dollars of expediting fees.
exactly. Yeah,
Yeah.
that's really cool. So did the Irish company find you, or how did that
Well, I
whole
knew them
thing
from.
work?
Well, I don't. Have you ever been to Scotland?
Mm-mm. No.
So Scotland, like Aberdeen, Scotland, is very similar to Houston, Texas. It's like the oil field business of the North Sea,
Okay.
and so I knew a bunch of people from the oil business there, and they knew a bunch of engineers in Ireland, and so because of that network of people, I was introduced to them, and they were like, "Hey, you guys are the U.S. is doing this cool wave energy project. We have been doing that for years. Do you want to partner up and we could help design it, and then you could build it in the States, which is a requirement. You have to build everything here in the States." And I said, sure, but I didn't expect to get this far. I expected to get through, honestly, because I didn't know anything about this technology before we started. So I thought that maybe we'd get through phase one, phase two, but we just kept on being successful, which was really cool. But yeah, that's how it goes.
That's awesome. That's super cool.
Yeah.
Well, we can jump into some questions. Like in manufacturing asked, and he was asking both of us, how do you get connected with good customers for prototype work?
I say look for tragedy. And what I mean by that is that, if you're going to a big company, it's hard to get a new vendor in there, you know? But if that company's in a bind and needs something now, like they would be willing to take you in. Like that's the best way. When I was working at the big company, that would always be the time I'd find new vendors. Is I'd be like I'd run to the purchasing guy and say I need this tomorrow, and he'd laugh at me, you know. And so I'd be like, well, I know this guy who has a shop, and the purchasing guy would be like, no, I'm not going to go through the trouble. And then I'd pressure him, and he finally would. He would do it. He would go through the whole ISO steps required to approve the vendor and all that stuff. And then once that vendor was in the system, it's very easy to issue a second PO for whatever. So
Right.
it's like, so yeah, really, it's like looking for tragedy, in my opinion. It's hard to get in when everything's going well. It's easy to get in when the company really needs you. So yeah, I mean, I don't. Other than that, I mean, in terms of design work, it's all happened very organically because of the network of people I already knew from before. And in terms of like manufacturing work that I do here, just like job shop type stuff, I don't do much of it. I only have maybe 3 or 4 people that I regularly do the same kind of stuff for. So I'm maybe not the best resource for that because I'm not a guy that has like 30 regular customers or 40 regular customers and I'm just like living awesome. That's really not me or my business. So
Yeah. Well, I think that even the guys with 30 or 40 customers, as you found out, it's not an easy life
oh
regardless.
yeah,
So,
sure, yeah, for
but yeah, I mean, I guess my answer to that is like the same thing. Like I have done zero paid advertisement. It's all been word of
right,
mouth. It's all been people I knew from, the U of A or just customers talking to other customers. It really kind of going back to your point of like the universe conspires to help you out. It has
yeah,
very much felt like that. Like every time
right,
that I'm like, oh, we need like a few more big customers to make this next leap, and then it's like there they are, and,
yeah,
and maybe I'm just lucky, and that that luck will dry up. But yeah, it really has been just do good work and do the kind of work that I would want to support and would want to buy from, and
yeah,
then the customers show up. They, like you said, they need a shop, then they need to do stuff real
right,
quick, and they're like happy to onboard anybody. So
yeah, yeah, for sure. Tragedy is the way to go. Definitely look for like a panicked engineer. Someone who's or like or a purchasing guy. I mean, if you can like LinkedIn some purchasing guys at some of these big companies, and somehow like I hate to say creep on them a little. But if you creep on them a little, cause what's weird is that at my first company, they had their own purchasing department. Those purchasing people and the managers especially were actually evaluated on their ability to bring in new vendors. That was one of their metrics. It's like,
Right.
how have you built vendor relationships? And I didn't know that, but like if you think about that, that means that if you find someone who's in like a purchasing department of any of these big companies, and they just know you exist, and maybe they won't approach you at first, but over time they need something. They're like, oh, wait a minute, that guy. Well, this is gonna make me look great. I'm gonna like onboard this guy. He's gonna make us some great parts, and then I'm gonna look like a hero. So maybe even in big companies, I don't think knowing the engineer is the best way. It's probably knowing the purchasing managers or the buyers. At a small company, like 10, 15, 20 people, all of them, then you got to know the engineering team because they make all the decisions. So,
Yeah, but I mean, you could figure that stuff out from LinkedIn. Even
Yeah,
you find
yeah,
one email from that company, and their algorithm or their formula on how they build
right.
their emails, and you just find somebody on LinkedIn that looks like you want to talk to them and send them an email.
Yeah, sure. Yeah, you could do that. I mean, when you're running a business, there is no shame. There's no
Right.
such that. What you don't want to do though is be like, LinkedIn connection, and then like 5 minutes later, you're like, hey, I'd like to help you out, and I would like to give you all these things, and how about we schedule a call for tomorrow? You know what I mean? That's
Right.
what all the people on LinkedIn do. And I don't know about you, but every single time I get one of those, I immediately disconnect from them. Uh,
Same. Oh yeah.
no one wants to deal with that, right?
Yeah. If you appear like a bot, even if you're not, even if it's just a formulaic response or whatever, I'm immediately done. Like I'm like, all right,
Yeah,
I'll talk to a real human any day that
absolutely.
clearly has written this email and not just copied and pasted and put my name in it.
Right, right, right. Yeah.
The other question we had was from Flux Work Holding, and he wanted to know all about those bellows you just showed
Oh
off.
yeah, yeah. So like silicone. So like at my old job at Walls and Krinzer, I had to sometimes prototype gaskets. So I got into the world of 3D printing molds and eventually machining molds and making things. Basically, silicone you can buy it two ways. You can buy it as a two-part liquid, or you can buy it as like a putty that's heat. And I've had a hard time finding the heat cured stuff. So really, if you're small scale, maybe I'm wrong about this, but I think that the liquid is the way to go. What sucks about silicone is that it's not a thermoplastic, so you can't heat it and like extrude it like you would like other plastics or injection molding and things like that. It once it cures, it actually has a really high. It doesn't even. I don't think it has a melting point. I think it burns. So it's a little tricky because all the normal thermoplastic processes you can't do. So you have to make a mold that you can actually either inject it and let it cure, or pour it or something. But with the bellow, what I'm doing is I'm making a sacrificial inner mold out of paraffin wax and then melting it out afterwards. Because you can't, what blow molding is like with bottles and stuff.
Yeah.
Yeah, you like inject like a tube of thermoplastic, and then you clamp it on the outside with the die is like exterior, and then
Hmm.
you blow air and it expands out. Well, you can't really do that with silicone. So what I wanted to have a seamless bellow without having sections that get, because vulcanizing silicone is bad too. You can't really do it very well. So basically, my plan right now for those bellows is to basically mass produce the paraffin sacrificial molds and then make a batch of bellows and then put them in the oven and then melt out the wax on the inside. And then you have a perfect silicone bellow with no seams or not like anything. And it could probably hold quite a bit of pressure.
Yeah, it looks
Um,
super cool. I was
yeah.
really impressed. So the part that you had made, then you're forming around those for a mold for the paraffin wax.
Well, so I made those just to see if I could peel off the exterior without damaging the bellow.
Okay.
And the answer to that was no. Like, yeah, I mean, I think, yeah, Jake Yates made a beautiful mold for me. And unfortunately, it's now a paperweight because the silicone just wouldn't tolerate it when I tried to peel it off. If you look, I looked at some videos in China of people doing the same thing, and they were able to peel off the exterior of the silicone
Hmm.
without damaging it. But they were using less aggressive rake angles on the bellows, and so, but with mine, it just didn't work. It would tear. So the only way I'm going to be able to do it is to have a sacrificial inside and do it that way. But yeah, that's how you do it. You just pour it like any other thing, and you can do fancy stuff with it. The nicer you make your mold and the more creative you are with your reliefs. I guess in injection molding they call them sprues, like the pieces, the ports that allow the fluid in, or is that the wrong term? I'm not sure.
I think
But
that's right.
yeah, whatever they are, the things that let the material in, you have to be a little creative with that, just like in any injection molding, so that you don't have air pockets. And you have to, with silicone, you have to degas it. So when you mix the part A and the part B and your color, and you have this liquid silicone rubber, it has to go into a vacuum chamber to get all the air out. And there's a ton of air. You'd be surprised when you actually vacuum it up. It's like a volcano and it explodes out. And then you put that into some sort of injection device. It can be a syringe or anything else, and then you inject that into the mold, and you just design the mold so that air doesn't get trapped. And if you do have an area where air gets trapped, you have to put another port to let it escape.
Right.
um, and that's how you do it.
That's cool. So is that for the waves to water?
No, that's so I have like a long-term project, like a long-term robotics project, that it's one of those things where I'm racing to release it before I run out of money. Like it's like a race to the finish, and I'm probably like 2 or 3 months from being able to have a functioning item. But basically, have you seen the show Westworld?
Yeah.
Like season one, particularly.
Hmm.
Yeah, so that show, like, I really liked that show, and it had a bit of an effect on me. It made me question my reality, the nature of my reality. And so, I've designed and used tons of hydraulic cylinders, electrical actuators in my job, very familiar with that, how it works. And I wanted to make an actuator that had no metal, that was basically sized. I wanted it to have the look and feel and size of a human muscle. So that bellow that you saw was actually sized for like a male bicep. And if you look on the website, you can see a picture of the complete muscle. I call it a muscle. It's really an artificial actuator, or a soft actuator that looks like a human muscle. And basically, the idea is to have a non-metallic, soft actuator that looks and feels and is sized like human muscles, and that performs kind of like them as well. And instead of running them, so in robotics, most soft actuators are vacuum driven, like they suck instead of push fluid.
Hmm.
And this one is the opposite. It actually is positive pressure. So, you can either use air, or I'd really like to use a biocompatible like hydraulic fluid. And I don't know. I don't know why the project captivated me so much, but I have some friends from the military that work in the biomechanics field. And part of me feels that if I made a really good synthetic muscle, it would be sellable. But it's been really challenging. Like it was way harder than I expected to make it work, which is probably why there's not really good ones on the market right now.
Probably.
But I'm gonna take it. But I'm gonna take it to the end though. Like if I gotta drive it into the ground, like I'm taking it to the end.
All right. All right.
All the way to the bottom if necessary.
That's cool. That's super cool, though. I look forward to seeing how that all works out, because
Yeah.
that sounds like such a cool end goal.
Yeah. Well, thank you for having faith in me. You might be the only one.
So you had brought some things up in our DMs that you might want to talk about, as far as CAD CAM opinions or what you like
Oh
in
yeah, yeah,
suppliers. So
yeah. And if you don't mind, I have some questions for you because I don't often have an audience of like real professional machinists to like bounce things off of. So I got a
shoot.
couple questions too, if
Yeah.
that's all right.
No, I told you that
Um,
this is just a
yeah.
casual conversation. So shoot.
So can we talk about vice torque?
Okay.
I suspect that I am one of the offenders of over tightening my vices. I suspect. What kind of torques are we talking? Like, give me a range of torques that I should be expecting to be in, because I've thrown a part once, and ever since I threw a part, I tightened the heck out of my vise. And I can see though when I put a dial indicator on the top of my parts, if I tighten it down, I go past a certain point, and you can see that the indicator will start to lift the part. You can see it. It's there. It's real.
Oh yeah.
Sometimes it can be a lot, 3/4,000ths or whatever. So is there a range in actual measurable units that is a real thing, or is it just experience and that's all?
A little bit of both, especially second op stuff like soft jaws. I'll use a torque wrench, and I'll try to get the least amount of clamping force, especially if I'm trying to hold flatness or anything like that. So I've gone down as low as 5 foot-pounds.
Oh God, okay, yeah, I over tighten
Um,
my stuff.
but like I also have torque stuff to 80, 90 foot-pounds for
Yeah.
first ops. Like I'm running a part at work, and the billet is 9 by 9 by inch and a half or inch and a quarter, something like that. and I put an indicator on it because I'm using Sarah jaw strips,
Yeah. You
and
told me about those. I should look into those.
I love them. I mean, I've thrown apart from with them because of a rounded corner on the bottom of the stock. You know, the bar stock has the
Yeah,
slight
yeah.
radius, but like I'm clamping that billet. It works so hard that I put an indicator on it. And what I end up doing a lot of the times, if I need a lot of holding force with those, is I will over torque them to the point that, like, I mean, it was bowing 10, 15 thou in the center, and
Oh,
then I'll
really?
back it off and then just seat it in there. So I'm kind of doing a faux laying macro grip kind of thing where I'm
Yeah.
stamping the part and then seating them in there. And then I was only going to 20 foot-pounds and it was holding totally fine because now it's got that
Okay.
step to sit in. But yeah, I mean, torque, there are, equations you can use and blah, blah, blah. I think a lot of it ends up being feel, a lot of it ends up being experience.
So what you're
Also,
saying is no, Brandon. There is no answer.
yeah. I mean, like, I think a lot of it too is you have to know when it matters. Like with the Sarah jaws, and I've got a square, in the x-axis, I've got a square piece of stock, like maybe a 2x2. There's almost no amount of squeezing that I can do with those jaws that's going to show any measurable effect on the top of that part. You know,
Okay. Yeah.
but like if I have a half-inch thick plate that's 5x5 or 4x4, it's going to take a whole lot less torque to deform that. So
Yeah,
it's
yeah.
kind
I
of
gotcha.
balancing that, like how aggressive I'm going to program it and how many parts I got to run. And, there's just so many factors that go into where I torque parts at.
Yeah. Okay. That's interesting because I could calculate I could do the friction coefficients of the jaw and all, and I have a feeling that if I calculated it, I would be like so wrong, it would be laughable. Because there's so many variables that are there. I mean, think about it. Every time a flute hits a piece of metal, it's basically a micro impact.
Yeah.
And how is that accounted for? It's not. I mean, it'd be really hard to calculate a vice torque in a realistic way without just like experience, without
Yeah.
just
Well, not only that, but the helix creates an upward force.
right. Yeah, that too.
And with a variable helix, like I've never seen an equation where you can like give it a model of a tool and be like, calculate the up force from this depth of cut. So yeah, there is quite a bit that goes into it, and I think there's some best practices, and a lot of it's just experience. Though I hate to say it, but
Yeah.
like a lot of
Okay.
things in this trade, it's like,
Yeah.
I've thrown enough parts now that I know how tight I can go or how loose I can go, and
Yeah.
uh, but definitely second op stuff. I torque wrench and I try to go as low as I can, and I find that down cut end mills help a lot. I mean, anybody who will listen to
Yeah.
me,
Yeah.
I've preached the benefits of that AB Tools down cut half-inch tool that they had, and now they've got, I don't know, 4 or 5 different sizes of them. But I mean, I've held parts that are 30 thou thick at 5 foot-pounds and rough them at 200 inches a minute with that cutter and
Wow. Yeah. You,
zero
you guys.
pull out.
So I have a VF2 now. I don't know if I said that before, but I sold the Tormach and I got the VF2, and my spindle load on my VF2 never goes above 30. The only exception maybe is like if I drill like a 1 inch hole with an insert drill,
Mm-hmm.
it'll go up to like 80. But I really like my VF2 since I got it. Like I baby it really a lot. It's whoever happens to be the lucky person to buy my machine from me when it's time to sell it. I mean, it's like in really good shape. It scares me, when I start. But I did buy an orange vise because I thought my vices were too weak. But like we said offline, it's 3 week or 4 week lead time, so it's not going to be used in the next month. But yeah, like throwing parts is not good, man. It's like a jarring experience.
Yeah, yeah. It's one of those reminders that this trade keeps giving you. Like
Yeah,
you're not done learning yet.
right.
I threw that part, I don't know, maybe 4 months ago or something, and yeah, I was like shaken for the rest of the day. I was like, I'm probably just gonna go home. Like, I actually think I finished out the parts because I was like, I don't want to go home on a bad note. But it's it sucks. I think that
Yeah,
Sarah jaws and clamping devices like that really help my confidence for op one. Like soft jaws also great, but like flat jaws, I've never gotten as good of a feel. Like a lot of it's just like, do I feel good about this setup? And like I've pulled more parts out of flat jaws than I have anything else. That's for sure.
yeah. So it's basically experience.
Yeah, yeah,
Yeah. All right. Well, I was hoping it was a little easier than that, but I guess I'll just have to take that and run with it.
yeah. Yeah, I would just experiment. If you're
Well,
doing, yeah,
I do pretty good now. It's just I think it's just a little too tight, a little too snug.
yeah, yeah. Well, I mean, yeah, grab a torque wrench, start playing around with it. I think that for most second op stuff, unless you're getting stupid aggressive or it's really tall or long depth of cut, 20 foot-pounds is usually what I go to,
Right,
if not under. But again, that it's very dependent on the part that you're doing and your parameters and all that.
right. Okay. Well, thank you for that.
Yeah, of course. What else you got?
Well, I don't know if I should leave these because this is like a holy this will be like a very opinionated question. Coolant or no coolant for mild steel? Go.
Oh man, you are asking the wrong person. I have done, I
just ran
think,
some. Okay,
one mild steel part in the entirety of Protium's existence. Maybe two.
Seriously?
Oh,
That's
we
so
do
weird.
almost none. It's either aluminum or it's like stainless or titanium. But there is no like. I think I've done, like I said, like one or two 1018 parts over the years, but typically that's not my go-to.
Okay.
Like in manufacturing, the one who asked the question before,
Yeah.
he knows his stuff. Like he does a ton of mild steel. So I would reach out to him on Instagram if you had a
Well,
question.
I just did a first article on some 1018 this morning, and I tried no coolant, and it worked awesome. I couldn't believe it. And last time I ran it, I used coolant, and now I'm starting to get it that there is some weird thing that happens sometimes at certain speeds and feeds certain tools that it just seems to be happier with no coolant. It just blows my mind because it's like, well, if it works better in steel, why is it different in stainless? And because stainless, it's like universal. You use coolant, period.
Because
And it's
stainless
like,
will work harden, whereas mild steel typically won't at cutting speeds and feeds, I think.
okay, well maybe that's it then.
Or at least stainless steel work hardens significantly quicker and easier than mild steel.
Okay.
And maybe somebody will reach out to me after this and be like, "You're an absolute moron. That's not the case." But
yeah. And
that's
anyone,
what I think I
anyone can
understand.
email me. Anyone can email me at brandon@markzeropro.com and tell me that I'm a moron, and that's fine.
Yeah, no, I'd reach out to Devin at Lycan and ask him anything you want, because I mean, there's been a few him and another guy on there's like a brother, not WhatsApp, one of those messaging programs, but he was showing a video of, I think he was doing 600 inches a minute in 1018 with like
Yeah.
a 3/8 or a half inch end mill and just air blast. It was
Yeah,
pretty
that's one thing I
impressive.
wish. That's one thing. Now that I saw that this morning with the steel, that's the one thing I wish I would have gotten extra on my VF2 was an air blast, because now that I know how good it can be running dry on mild steel, it would be nice to blow the chips out of the way too. Although, like this morning, I must have had the speeds and feeds just right because I had like a beautiful rooster tail coming off and getting everything out of the way. Everything was just kind of like lining up the way I wanted it to. But still, an air blast would be pretty nice.
Yeah, yeah, but yeah, I'm unfortunately not the right person to ask about
Okay.
that. I
Well,
appreciate it.
thanks. It's okay. Thanks anyway.
Yeah. So what about CAD CAM opinions?
Oh, so yeah, I was just going to mention this because I know that this has come up a lot on your podcast about. So I've used NX, SolidWorks, Inventor, and Fusion. All of them I've used professionally, like day in and day out. And in my opinion, I recommend Fusion to everyone as long as your assemblies are 50 parts or less regularly. I think that if you push past the 50 part limit in the assemblies, you start to see Fusion start to fall apart, and that's when you won't have a choice except to go up to the higher packages.
Right.
But I just bought the product manufacturing package, which includes Inventor. It even has Inventor Cam Ultimate and stuff like that. And it had some 3D graphic stuff in it. I bought the whole thing. AutoCAD, it's pretty expensive. But I did it for the first month. I did it monthly because I wanted to make sure because I remember Inventor from before and I thought it was excellent. And so, but I was like, I've been using Fusion for a while now. Before I leap right back into Inventor, let me just make sure that nothing's changed and it hasn't gotten worse. And I got into it for a couple days because I had this design job that has a big assembly, and I canceled my subscription. Like, I was surprised how it reminded me how much I used to suffer when I was designing in those packages. I think that the exception, I think like NX, like a lot of people look at NX as like the pinnacle of CAD CAM, right? And in my opinion, NX really shines in a big organization because NX uses like something called Team Center. Are you familiar with that?
I've heard of it. Yeah, I haven't used it.
Yes. So if you're like a big company, what you do is you get NX with Team Center, And Teamcenter manages your whole product lifecycle and all your engineering stuff. And everyone in your whole organization, thousands of people, can reach in and change the model. And then that same model goes directly to the manufacturing department. And like if you release a job for manufacturing, it'll send an email to the manufacturing engineer saying, hey, this is in your queue, it's ready to go. So NX really integrates well into like companies. If you think of like General Motors or SpaceX or whatever, where you're having to manage enormous assemblies and you have to revision control every single thing, and you
Right.
have to have approval processes for every single thing, including design and manufacturing releases. So like if you're not doing those things, in my opinion, don't waste your money on any of those other packages. Just stay with Fusion, because the thing that really made me cancel my Inventor license was the actual cam package, because I opened it up and I paid for like this amazing package, and it did have 5-axis, but it didn't have inspection probing.
Right.
Inspection probing is only in Fusion, not in Inventor Cam. And Inventor Cam uses the same software as Fusion. It's like just embedded in Inventor. It's like an extra tab in Inventor.
Right.
But
Yeah.
it's like wait a minute. So I'm going to pay like 3 or 4 thousand a year, and I still can't inspect my parts with my probe. Like that's insanity. Like I
Yeah.
shouldn't have to export this back to Fusion to do that.
Yeah. I think for 80+% of people and parts, Fusion is more than enough. Like unless you're
Yeah.
ITAR or something, you need something outside of that realm, or you need crazy 5-axis toolpaths or crazy control. Because I've seen, Greg at Luma Labs has NX Cam, and like
Yeah.
some of the things he's shown on the Discord, it's insanely powerful. Like it's up
Right.
there with a Spree, where you can do crazy 9-axis mill turn and all that stuff that
Right.
I
Right.
wouldn't really want to touch with Fusion. Like he posted a video, and there's a feature in there where you can just walk a tool through all of the points you want it to go to. So like if you needed to take a lollipop down and plunge through something, or plunge through a
Yeah.
hole and
Yeah.
then turn it 90 and get up, and
Right.
like you can do all that with this one toolpath in NX. So like it's got
Right.
more control than you could ever need. But
Yeah.
yeah, if you're doing 3-4 axis parts in a VMC, like I agree. I have yet to see a big reason to spend, like even Fusion with the manufacturing extension is less than the maintenance on an NX license. Just the
Yeah.
maintenance, not to mention
Right.
the first purchase, or if you're doing it monthly. So
Right. Right. Right.
it's tough. Like it's definitely it would be tough for me to pony up that kind of money when I know that for $500 a year, if not less when it's on sale, like I can get
Yeah.
Fusion and do 90+% of the parts that I've
Yeah.
seen.
Yeah. Right. That's right. That's right. And I wasn't trying to badmouth any of these other packages. I just am trying to be honest about it's having seen the other side of the fence in deep detail. I don't see the value in it unless, like I said, 50 parts or more. You start to see artifacts in Fusion that really start to get to you, and the drawings start to become restrictive.
Oh
Um,
yeah, yeah. The drawings in Fusion are atrocious.
Yeah,
But
but who cares? I mean, like if you're making your own product and all you need is a drawing with dimensions, who cares? And plus, if you're still doing that, I mean, why even do that anymore? Why don't you just do a 3D export and put your criticals on there and do a minimum dimension drawing? Save yourself all that time. I mean, if it's your product, why spend your time and money making a drawing anymore? If you're using vendors that require it, maybe it's time to find some new vendors.
yeah, but yeah,
You
I'm a
know?
big fan of limited dimension drawings. Like I
Yeah,
tell, I've got quite a few customers. Probably the majority of my customers don't have drawings most of the time. It's just
yeah,
like, here's the model. And then when I signed up with them as a vendor, they were like, this is our basic tolerance for everything. If we tell you otherwise, then great, but otherwise you need to hold it to this for everything. And it's like, okay,
yeah.
cool. Like
Right.
that's good with me. Like it's all prototype stuff. They don't care about, most of the time, and I was just talking to somebody recently about this. Most of the time, I'm not competing on price. It's, is it good and is it on time? So
Right. Yeah,
like
yeah.
they don't care if oh well, that overall really could have been plus or minus 20, but we don't care. But you're gonna have to hold it to a much tighter tolerance because that's our general tolerance. So
Yeah. Well, to you and all your listeners, if we're fortunate enough to get through this final phase of Waves to Water, our whole team is going to have to focus on the pump. So my plan was to take all the components that are not related to the pump and just shotgun blast them onto Instagram, because I don't care if they're not proprietary. I mean, they're just like brackets and like manifolds and stuff like that. Like I'm just gonna blast them on Instagram, and whoever wants to quote them can quote them, and because like it's not something that we can focus on. So hopefully we get through and we can do that because that would be a lot of fun.
Yeah, for sure. So one thing I wanted to touch more on, we talked a little bit about it, but was when you went full time. What went into the decision? What kind of things? What kind of metrics were you looking for, or lack thereof? You know, like what?
Ride the dragon, man.
Yeah,
Yeah, I don't know.
what did you need to hop on the dragon? You know, like what went
Yeah,
through your head, and what? How did you work that with your bosses? Because we were also talking about that. Like,
yeah,
I'm still working at a place that I really like, and it was tough to kind of negotiate that and feel good with the decision.
yeah. Well, I did what you did. I gave my bosses a long uh, notice and gave them the opportunity to like hand off all my projects over time. So I did that. My bosses at Walls and Crimson were excellent, man. They were really good engineers, really good managers. So I didn't want to screw them over. Um, yeah, and let's see, metric wise, I mean, at the time, I just had enough. Like I put enough money in my business. I separated my personal finances and my business finances first, and then I built up enough of a cash reserve in my business account where I felt I could last for about 3 months. And then I said, screw it, like
Time to go.
ride or die, dude. Yeah, you know what I mean? Like, because I'm 30. I mean, I'm 37, and I was 36 when I did it. And it's like I'm not getting any younger. I've always wanted to. It's only so, like I had a couple. I actually made a couple notes about this because I thought you might ask. Like, the first is like don't wait too long to do it because it does get harder as you get older and you have kids and stuff. A lot harder to go off on your own. And like we already talked about, the universe will help you to a degree, but like not completely. Like if waves to water, we don't get through this phase, and some of these design projects that I'm currently working on fall through, and the people that I machine stuff for, they like have a low period. I could be in trouble in 3 or 4 months. Like it's not like it's all roses.
Right.
I'm always looking out. I'm always looking out 3 months, going like, am I gonna make it? And like it's kind of lonely because no one's gonna experience that with you, and even the people close to you aren't gonna understand it. But I would say that you should, if you want to start your own business, you should do it even if your friends and family do not support you. And my friends and family do support me, but it took a little while for them to come around. Once they know you're serious, and like once they see that it's not going to be instant, you're not going to be instantly destitute. Once they see that, and they will then become a little bit more comfortable with it. But let's say you have a wife or a friends or family or parents that completely don't support you. My recommendation in that scenario would be do it regardless, because what you can't be a slave to someone else's life or lifestyle. So, whether they support you or not, you have to do it. Like I said, I'm fortunate that my family does support me, but it wasn't immediate. It took some time for them to understand, like if they could manage the risk.
Right.
And what you definitely shouldn't do, in my opinion, is use your wife and kids as an excuse not to. I think, in my opinion, it's better for especially your children. It's better for them to see you try and fail. It's like dare greatly, or because you don't want to be like those, what do they say, cold and timid souls that know neither victory nor defeat. So yeah, you definitely want to if you're going to fail, it's okay. Let them see it, so they don't grow up as meek and feeble and feeling like they have to always work for someone to live. If they don't want to, they don't have to. It's always a choice.
Yeah. Well, so on the flip side of that coin, what positive aspects can you share about going out on your own that you've really enjoyed?
I mean, just getting to like walk into a shop every morning whenever I want to. You will work longer hours for yourself. At first you might not, but it creeps up on you.
Right.
Like you start wanting to spend more time because you start to worry about being able to produce enough and being able to make enough money. But controlling your schedule, I mean, you'll find yourself feeling sort of proud that when everyone is complaining about their vacation and sick days that they're trying to use at this time or that time, or like sell back, or all those conversations, you just find yourself feeling like you have nothing in common with that perspective. It's complete freedom, but the novelty of the freedom does wear off because you just have a different boss, and that's your customers, and you have to behave yourself. I mean, no one's going to shield you from mistakes you make. People can come for you if you make a mistake, and people can sue you. There's a whole different set of responsibilities. But I would say the most positive thing is just the pride that you were brave enough to do it, because I spent years not being brave enough to do it. And once I did, I was like, man, I can't believe I waited this long. So, but that being said, I want to paint a balanced picture because uh, we could have a conversation 3 or 4 months from now, and I could be like, wow, this was a mistake, you know. But I don't think that I will. I think that if that happens, if the worst happens, I think I'll handle it with some level of grace. So
Yeah, well, I mean, I think just going over your backstory, you've shown that already. You know, you did your whole first project, and they were like, "We don't like this at all," and you're still here. You're still doing
yeah,
it. You weren't just like, "Well,
yeah,
manufacturing's not for me. I'm done." You know.
yeah, right.
Um,
Yeah, got to pivot a lot, you know,
yeah,
constantly pivoting.
yeah. Well, and I have yet to talk to anybody who's gone out on their own who's been like, "Man, I really regretted this."
Yeah,
Like my good friend who was the one really hard pushing me to go full time. He kind of put it out last year at the end of last year when I decided. He was like, "Listen, like worst case, you
yeah,
fail and you can find a job as a machinist anywhere, and now you're on track to be a manager because you've owned
right.
your own business." He's like,
Yep.
just get it out of the way. Like if you're gonna fail, fail, but give it a try. So
Yeah, that's exactly right. That's exactly right. And the chances are, I would also recommend to live small. Like if you're living big, you know, people tend to live at the upper end of their income, especially here where I live in the Northeast. I mean, all these people driving around like super nice cars in the Northeast, most of them are leased or they have reverse mortgages on their house or something weird, you know, where they're paying for it or equity loans on their house. You know, a lot of people's wealth is actually is not real, and it's just a front. So, and what it does is it ends up chaining you to whatever you're doing for money because you feel like you don't have the flexibility to do something else because now you're accruing all these expenses. So, you know, live small. Like if you can, like if you're living, I would say that if you could, you should always be living in the house that's as small as you can tolerate, with a car as cheap as you can possibly get away with, and try to like, you know, carry as little debt as possible. I think in a business, not carrying debt is maybe unrealistic because the capital expenditures are too big for most people. Now, I know like Dave Ramsey would disagree with me and say that there should be no debt ever. I think in a business sense, it's just not realistic. But, you know, in terms of your personal life, keeping the debt low, having my debt low helped me a lot starting the business because I wasn't worried about them taking my cars away or, you know, anything like that. Yeah, and what I'm saying might not be applicable to everyone because some people can't get out of whatever they're in. But if you are trying to set yourself up long term to do your own thing, you're not ready to do it right now, you know, getting your expenses down to a low level, maybe live in the middle of your income range or maybe the lower part instead of the upper part. That gives you way more flexibility and more survival because it's all about survival. You know, living that next, making it that next month, or if you have employees that next payroll or whatever.
right, yeah, I think that's a great way to look at it. I definitely, you know, a lot of my listeners come from Instagram, and I think we all know the dangers of that, like looking into other people's lives and this purported wealth. They're like, oh, well, they're
Yeah,
driving, you know, a Tesla and they've got this giant house. And yeah, little did you know that they're underwater on their both their
yeah, yeah,
loans and they're, you know, about to be destitute. So
yeah. Don't get caught up in that. I mean, it's not worth it. Who cares? I mean, like you gotta at some level, just like you gotta say screw the world. You know, I'm doing what I want. If I'm viewed as a poor, you know, soul who is barely surviving because he has the business that's not very good, then you know, screw them, man. It's like, what are you doing here? I mean,
yeah.
you only, I mean, I used to have a counter on my computer at work that had like my estimated days till death. You know, because if you could calculate it out using the, you know, the average lifespan in the United States, you know, barring any major illness, you know, you only got a certain number of days, and every day it would go down one. You know, and so if you think of it that way, it's like, you know, who are you working for, man? Like, who are you living for? Like, if it's anyone but yourself, it's probably the wrong answer. There's obviously some exceptions to that with your children because you do owe them the best you can give them, but that is by no means an excuse to not live the best life that you can. You know.
Totally. Totally. Well, I want to kind of transition into shop news and new things. Anything new that's going on in Mach Zero?
No, no. What I'm sticking with, part of me wants a lathe, but I don't know if I really want a lathe. You know, I kind of like the trend that I'm on now, which is a lot of the revenue is design related. I don't know how much of a shop I really want. I kind of like having a general purpose mill that does a little bit of everything, um, and that's kind of enough. Like if I really need something turned, I can send it to someone else. Measuring would be cool, like a CMM machine, but at the same time, like most of my customers aren't that stringent about tolerances. So like just this morning, I actually did some hand programming for my probe, and the part that I have on there now, it machines the part, it then checks all the critical tolerances, and then posts it on my control screen.
Hmm.
It adjusts the tool wear and then posts it on the screen. So every time I change the parts in the vise, I can briefly look and I know that that part's good. And then every 5 or 6 or 10 parts, I'll go and I'll double check that with micrometers and stuff to make sure the probe is giving me accurate readings. And that's good enough for me. I mean, that's good enough for my customers. So if that changed, like if I got some customer that wanted to run thousands of parts, and then I would definitely look into more advanced measuring tools.
Right. That makes sense.
Yeah.
Well, to wrap out the episode, I always ask everybody on the show, what have you been researching this week?
Oh yeah.
What have you been looking up?
You're a motorsports fan, right?
Yeah.
So I've been looking up information for the last couple months actually on 125cc shifter carts.
Okay.
Are you familiar with those?
Oh yeah. Yeah, I've watched a lot of YouTube videos of both super cool passes and crazy crashes and everything in between.
So when I was a kid, I had go-karts, but I never like raced them in any type of organized way. Me and my dad built one when I was young, but like I was recently introduced to there's a track in New York about an hour and a half from me. I was recently introduced to like those shifter carts and the fact they go like 0 to 100 and back to 0 in like, I don't know, 5 or 6 seconds or something. It's just like insane. It's like it shouldn't be. I don't know why anyone races cars after seeing those, because like, how can you get more performance than that? I mean, it's just insane.
Well, those are also a feeder usually, well, in Europe at least, for F2 and F3 and then Formula One. Like that's where all of those drivers came up in, is shifter carts. So yeah,
so they're about $15,000. They're like, it would be cheaper to race a Miata basically. But like I'm really captivated by it. My son, is decent. We've been going to a track and just doing rentals, And I really like. I'm trying to like war game in what universe I could possibly spend $15,000 on a shifter cart. But man, if I did, it would be awesome.
Oh yeah.
And the one thing I noticed about them is that a lot of the components are actually magnesium based.
Mm-hmm. That makes sense.
And I don't. And well, maybe you could explain that to me, because I've never designed or built a part with any magnesium alloy, and I didn't know that was a thing.
It's weight. That's purely
it's lighter.
all it is.
It's lighter than aluminum, I take it then.
Yeah. Yeah.
Okay.
Yeah, it's lighter than aluminum, but not as expensive and hard to machine as titanium.
Okay.
And a lot of those parts don't need to be super strong; they just need to be light.
Okay.
Yeah. So you'll find a lot of aircraft parts are also magnesium, just for weight savings.
That's interesting. Well, I thought it was pretty cool. I mean, it's definitely a low on the wish list, because there's a lot of things I got to pay for first before I buy something ridiculous like that. But I've definitely been researching it. So what about you? What are you looking into this week?
Well, we just finished installing AC in the shop, so I was deep into code and how to do all that.
Nice.
But yeah, it's life changing. Like
it's a world of difference, right?
Yeah. Well, especially, I mean, the last week or so, it's not only been rainy, but it's been our summer, so it's been like 105 degrees and 60-70% humidity.
Yeah, dude, no way.
Yeah,
like,
and so
that's awesome.
Yeah, we installed it last weekend, and like Tuesday, I think I went into the shop, and it was 80 and 25% humidity in the shop when it was like 105 outside.
Yeah, no way. Well, wait, hold on. That's the after AC.
That's the after AC. I mean, we're not running it like we have it set to 80 degrees also, because like.
Oh, okay, gotcha.
For us right now, 80 is super comfortable.
Yeah, I forget that 80 in your world sounds great.
Yeah, that's a 25 degree differential than the outside.
Yeah, well, that's great. Good for you, man. Like, I think that it's going to really improve your quality of work too, because there's just no way you can sit in a sweatshop and do as good as being comfortable.
Yeah. Just in general, my attitude this whole week has been better at the shop, just because I go in and I'm not angry immediately. Like, oh, I've got to, because like it felt just like swimming in your own sweat every single day.
Yeah,
especially
sure.
You run the machine and then you open the door and all the coolant mist hits you too,
Yeah.
and it's like, well, it's like 100% humidity and 100 degrees in the shop, and I'm over it. So
yeah,
that's
great.
Been great. Yeah, and then I've got the fourth axis that we bought recently that should be going on the machine, I think, in the next week or so. So
do you have the manufacturing extension infusion so you're gonna be able to do like rotary paths and stuff?
I don't yet. It's still on sale right now, and I've been very tempted to get it. I think most of what we're going to do is probably positional anyway, so I'm not super worried about it. But
Okay.
I don't know. I keep going back and forth. I'll probably pick it up eventually. I don't know if I'm going to do it right now because I still have to buy. I've got to modify one of my orange ZPSs to mount on the faceplate of it, and then I'm probably going to buy orange. It just came out with the 90-degree um, not tombstone, but little half a trunnion kind of thing. So then I
Yeah.
can mount one of my Delta Vices on it and use it that way. So there's a lot of expenses left coming for that.
Yeah. You have a really nice. I just saw you in your picture recently that you have a really nice, table setup. I should probably learn from you a little bit because mine's a little more random. I just got vices thrown on there, but you have it real organized. It looks like it's interchangeable and all that stuff.
Yeah, the orange subplate, it took forever to get on there. I mean, as listeners of the podcast know, it took me
Yeah.
far too long, but it has been amazing. Like going from, I usually have two vices right next to each other and then some empty ones and then my tool setter, and going from that to the vices on the furthest outboard ones, fully cleaned, installed, didn't have to tram them because they're already tram. I think it took me an hour maybe, and that's pulling
Yeah.
all the vices off, cleaning them all off chips, everything, loading them back on, and it's easy. Like it's the easy button for setups. I really
Yeah.
like it.
Yeah, I might have to pick your brain about that a little bit more if I ever. I mean, it's funny because like I always said to myself, if I ever have a big order that's worth it, I'll get an orange vice. And then I got a bigger order and I bought the orange vice, and then it's like a month lead time. I was like, well, never mind. I guess I'm not using it for this. And but maybe I should look into some of the stuff you're doing and replicate it so that I can do faster change outs as well. It's just hard to justify the cost of it all because I don't have to change things that fast that often. So it's like,
Right.
it would be it's a nice to have, but I don't know if it's really in the budget or worth it. But we'll see.
Yeah. I mean, I guess in your situation, it's not as an imperative. For me, it's like I haven't
Critical.
dealt with cap screws for jaws in 3 years, 4 years.
Oh, God bless you.
Like the carb smart stuff, like it kills, like it just kills the game as far as quick change out goes.
Yeah.
Like I buy
And
the carb smart jaw stock from McMaster now. Like it's a little more expensive than buying it from carb smart, but it's also next day. And so I've
right.
got a few 31-inch sticks just sitting on the shelf. I'm constantly using that stuff. I mean, I'll use it sometimes for parts that probably don't even need soft jaws. I'll just cut steps in it so that they're exactly where I want. I know they're perfectly tram and perpendicular to the spindle, and then perpendicular, square to the travel and everything. It makes my job. It makes me worry about less things. Like,
Yeah, yeah. And you told me you don't actually machine your own Carve Smart style jaws, right? You buy them. You don't buy them at stock either and cut them. You buy them completely done.
no, I buy them as stock. So I buy 31-inch sticks of
Okay.
it, and then I just chop it up with our chop because I very often, most of my parts are fairly small, so I'll use 2-inch pieces or 4-inch
Oh
pieces.
yeah, that's clever. Yeah, that's a
Yeah,
good idea. So you can save the material.
yeah, exactly. And then you flip it once, and you get at least two uses out of it. I mean, very often I'll get 3 or 4 uses out of a 6-inch pair of jaws, and so they more than pay for themselves in a job.
Yeah. So I've been on my soft jaws. I have my old Tormach vices on there right now, and I make my own jaws. I made like a batch of like 100 of them, and then let it sit for a few months, and I'll make
Yeah,
another batch. But
the,
maybe when this orange vice finally gets here, I'll do away with that and just go with Carve Smart.
I think I don't know. There are trade offs. I think if you have extra time, making your own jaws makes sense. But like for me, I mean, the whole reason we even bought the brother in the first place was that like we were trying to optimize every second I was in the shop because I wasn't full
Right.
time. So it's like I've only got 4, 5, 6 hours every night, and then the weekends, and it's like I need to optimize every single minute I'm there. Like I don't want to waste time setting tools. I don't want to waste time, using a hammer or a edge finder. I don't want to waste time changing out cap screw jaws anymore or worrying about like, oh, I need to make more jaws this week. Like that, all of those little things add up to so much time that for me, it makes a lot of sense to go that way.
Yeah. Yeah. Gotcha.
But
Your brother, you have the 10K spindle, right?
yeah, we've got the high torque one.
Okay. And do you think that was a good choice, or would you have wished for the 16K?
I really enjoy having the 10K. I think if we bought another one, I would get a 16K so that I could have a specifically like aluminum surfacing machine. Because there
Oh
have been
yeah.
times where I'm like using a 20 thou end mill, and I'm
Oh
like,
yeah.
man,
It's the
having that
worst.
extra 6,000 RPM would be awesome right now, or
Right.
surfacing. It's like, man, I could really push some more surface footage here if I had 16K. But
And do you ever wish you had more tools? I mean, because the brother has what, 20
21, yeah,
tools?
well, 20,
21.
20 with the probe.
Is
Yeah,
that
I
ever
mean,
problematic for you?
very rarely. Most of my part, like I have used 19 out of 20
Uh huh.
on a few occasions, but it's very rare that I'm like, oh man, I'm out of tool holders now, or I'm out of tool positions.
Okay.
But with the fourth, that might change because now I'll have 3, 4 sides of a part that I can access. So we'll see.
That's gonna be so cool. You gonna post some videos about that?
Oh yeah, yeah, yeah. I'm hoping I need to make a subplate for it, or an adapter plate, because the the bolt holes on the fourth are like 150 thou from lining up with the bolt holes that are already in the subplate. Because like when we
Oh,
bought it, I had thought like, oh, I'm going to mount it on a subplate that can go on the ZPSs, and so like I don't need to worry about having holes configured for it. But if I did that, I would lose so much Z that it wouldn't make any sense, because it would
okay.
be
Yeah,
I think the ZPSs are an inch,
you're
the
right.
subplate's an inch and a half, plus an
Yeah.
adapter plate. It's like, man, I just lost 4 or 5 inches.
Yeah, I think I told you offline. I think that was the main thing because I had a Speedio quoted when I was shopping for my VF2,
Right.
and I think the straw that broke the camel's back for me was just that Z travel,
Yeah.
because you've seen some of the weird stuff that I put in. I'll put like huge pieces in here to like put a hole in the end of the rod or whatever, and that was really the thing that I think pushed me over to the. I still like the Speedios, and I like actually the DTs, but I think you guys recommended against that because it wasn't big plus.
Yeah, and I've heard some scary things about the DTs. Like the
Really?
fact that you have to bolt it down.
Do they walk
It,
around on the floor?
yeah, and like and I've seen brothers do that too. Like there's a shop in Phoenix that has a bunch of the M140s, and they
Okay.
had to chemically glue all the machines down to the concrete floor because they were starting to walk, because they were
Oh.
I think they were running oil either in those machines or in machines next to them, and so with the oil on the smooth floor, it was just starting to walk a little bit.
Oh,
But
no
like the
way.
DTs, from what I've heard, like they have to be bolted down or they'll shake themselves apart more or less.
Oh, I
And like
gotcha.
I'm sure somebody's going to correct me on that, but I've heard of them eating them, like the spindles eating themselves, or
Oh, really?
losing timing on the watchdogs and stuff, and like it just I from what I've seen, Peyton really liked his DMs. I would steer anybody towards a DM over a
Yeah.
DT any day.
Well, I'd like to say that my VF, if you're looking for me, I would always choose simplicity of use over accuracy. So just having like a VF2, plain old VF2 for me was the right choice. It's just a general purpose machine that's good enough, you know? For someone in your position that might not be good enough. It might be worth it to have those extra tenths and the higher speeds and stuff. And there is a universe where I would buy a Speedio for sure because I think they're awesome. Not anytime soon though, I don't think.
Well, and I think I've told quite a few people this even recently, that like I think for a certain set of parts, there is no better mill than a Speedio as far as cost goes. But if you are working outside of that envelope, it's going to be a pain in the ass. Like I'm not
Right.
standing 10-inch parts up on my mill to drill the ends like you are. And if I
Yeah,
knew
yeah.
that I was doing a lot of that kind of work,
Yeah,
no
yeah.
way would I've gotten a Speedio. But like I know that most of my parts are 6 by 6 by 6, if not smaller. They usually, are much smaller in Z than they are in X and Y. They rarely have end ops, and it's like for that kind of part, man, the Speedio just kills it. But like,
I've never been in a room with a Speedio. I would love to go if I don't think that I ever would anytime soon, but if I'm ever like in the west of the United States, I'd like to like see one and actually feel the. I've been around robo drills,
mhm.
in person, but I've never actually stood in a room with a Speedio running. I'd like to.
Yeah, if you're ever out in Arizona, come on by. You're more
And
than happy to.
now that it's got AC, I can actually say yes to that offer.
Exactly. Yeah, you won't be walking in and being like, "Nah, I think I'll come back."
I'll be like, no, it's not worth it, bro. I don't
Yeah.
want to see it that bad.
Yeah, no, they're like, we've got Speedios and Robos at work, and they're very similar sounding, but the brothers, all of their drawbars are physically activated, like there's no pneumatics. And actually
Oh,
the
really?
Robos might be that way too, but they make a very loud banging sound going up and down into the tools.
Yeah, gotcha.
And if you're not used to it or you're not expecting it, it is a little jarring. Like I know when we got the Speedios at work, everybody who was running them was like, they're I feel like they're crashing all the time, and it's like, no, that's just
Yeah,
the tool change. But
yeah, I gotcha.
yeah,
Oh, do the brothers have a safe mode, quote unquote, like the Haas's do?
no, as far as I know, I think they're the only ones who are using that right now.
Oh
Haas.
man, that might be another thing that keeps me on with the Haas because I use it almost every single time. Yeah, I mean, I think I even because even run the spindle up to 80% doing a drill, it doesn't trigger it, so it's not like it's you have to baby it too much, and it prevents you. I mean, if you smash into the table, which I've never done, but if I did, it should stop,
Right.
which is cool. And for someone like me who went from a Tormach to a real machine, I like having that extra safety factor because I don't want to have to stress about it too much.
Right. Yeah, I know like one of the Matsuras at work has a similar thing for spindle crashes, but I'm not sure if it utilizes the same logic that the Haas one does.
Hmm.
Because the Haas one, like it's crazy because it's only fairly recent too. I remember when they introduced it at IMTS and they were kind of
Yeah,
just
like it was
showing
like
it off as
2 years ago or something, right?
yeah, yeah. So it's cool to see that they've come along to the point where you're comfortable using it and running it like that.
I run it like literally every day. Like if it's a first op on a part, every time I have it in safe mode, and it's never falsely triggered because I worried that it was going to give me false, especially if I was taking deeper cuts. But maybe part of the reason is because I don't take that deep of cuts and my spindle load's never that high. It's never like a risk. But I just like I ran that YG high feed this morning, and I don't know, that was probably up at 30 or 40%, and it's it doesn't trigger or anything like that. So I really enjoyed that. Maybe I would get confident enough to do away with it and get a higher end machine without it. But I really also like that in theory, should never crash. We'll see. We'll
Yeah.
see how that goes.
Awesome. Well, I really appreciate you taking the time for coming on the podcast. It's great to get to talk to you a little more outside of DMs and put a face to the name and all that stuff. So I
Yeah,
appreciate it.
sure. Thank you. I appreciate it. I honestly never expected to be on a manufacturing podcast of any kind, but I do appreciate it. I'll make sure that I get on your Patreon and start chipping in because I guess I've been dead weight so far.
No, no, no. I don't begrudge anybody who's not on the Patreon. But speaking of that, if you want to support the podcast,
Yes.
patreon.com/within tolerance podcast. I really appreciate anybody who is contributing. I don't think I have any new ones to mention this week, but I do appreciate all the patrons. It's a big help, keeping my costs low and letting me do this and keep it fun.
Yeah.
So,
All you freeloaders out there, get on there.
well, Brandon,
Me being one of them.
yeah, no, like I said, I don't begrudge anybody. I'm not doing this for the Patreon. It just helps cover editing costs and all that. So, but thank you again. Thank you everybody for listening, and we'll see you next week.